All right, this is section 4.3, exercise 9. So we're given graphs of a pair of functions, and we're asked to compute some integrals. So we want to find the exact integral, or the exact value of this integral, the integral from 0 to 1 of f of x plus g of x. So we're going to apply some different properties of integrals here. First one I'm going to apply is this. If I have an integral involving sums of functions, basically the integral of a sum of functions comes out to be a sum of the integrals. So the thing I am given is equivalent to this sum, the integral from 0 to 1 of f of x plus the integral from 0 to 1 of g of x, both with respect to x. So now I have graphs of functions, and how do I compute the integral from a graph? Essentially, that's going to come from finding the area between the curve and the x-axis on this unit interval from 0 to 1. So let's go ahead and do that now. So this integral from, let's actually just do these one at a time. This integral from 0 to 1 of f of x, we are told that all of these functions, basically every part of this graph, these graphs are either circular or linear. So this one's clearly linear, which means I will find the area of a triangle. So 1/2 times the base length, which is 1, times the height, which is 2. So the value of this integral is 1. What is the value of the other integral? So this is going to be a circular area, and it looks like it's a quarter circle. It's also below the x-axis, so I believe this is going to be a negative value. So negative, what's the area of a circle? Pi r squared, except I have a fourth of a circle, so negative 1/4 pi times the radius squared, which is 1. So that's equal to negative pi over 4. All right. So I have the integrals of both these functions individually. So how does this work basically now? So I have, let's just kind of string some inequalities together to show how these properties work. What I was asked about initially was the integral of a sum of functions. But I can decompose this into the sum of two simpler integrals. So the integral from 0 to 1 of f of x dx plus the integral from 0 to 1 of g of x dx. And I found these things individually. So this is equal to 1 minus pi over 4. And since I was asked to find this exactly, I'm going to stop there. I don't want to approximate. So I'm moving on to part B. Determine the exact value of the integral from 1 to 4 of 2f of x minus 3g of x. Well, let's do the decomposition up front this time. So I can rely on some of the other properties you've seen and hopefully took notes on before you got to the exercises. This integral from 1 to 4 of 2f of x. Actually, why am I rewriting this? So the first thing I'm going to do is this. What we just did in part A is you can break up sums and differences. So I'm going to do that first. So I'm going to treat this as the integral from 1 to 4 of 2f of x dx minus the integral from 1 to 4 of 3 g of x dx. Something else we can do, we have constant multiples inside these integrals. The integral of a multiple of a function is equivalent to the multiple of the integral of that function. So kind of analogous to derivatives. If you want to take a derivative of a function and it has a constant multiple with it, you can basically kind of leave the constant multiple off to the side and deal with the derivative and then reapply that constant multiple. I am doing basically the same thing with integrals. So I'm going to pull these constants out of these integrals. And now in both cases I have, all right, now I'm looking at the integral over an interval of one function and the same thing with the other. So now let's start looking at the areas I care about. So the integral from 1 to 4. So I think for G, I'm going to have to split these up into 3 distinct areas. There's a triangle above the x-axis here. There's a trapezoid below the x-axis here. And is that it? That's actually it. Okay. But what about G of x from 1 to 4? So from 1 to 4, I think I'm going to have a small triangle below the x-axis, a larger triangle above the x-axis, and looks like a quarter circle above the x-axis. So let's start finding those areas. I should not call these both A, should I? Let's call these B2, B1, B2, and B3. So what is area 1? Area 1 is a triangle. So 1/2 times the base length, which is a half, times the height, which is 2. So 1/2 times 1/2 times 2, that is a quarter of 2. So 1/2. And then area 2 is a trapezoid. How do we find those areas? So it's going to be 1/2 times the height, which is not 2, but -2, times the sum of the two bases. So the lower base goes from 2 to 3, that's 1. The upper base goes from 1.5 to 4, that's 2.5. So what does that become? -1 times 3.5, so -7/2. So if I take these things together, what does that mean? This right here means that the integral of f of x dx from 1 to 4 is 1/2 minus 7/2, or -3. So now let's do a similar set of calculations to find the value of that integral associated with function g. So what is b1? b1 is equal to, that's a triangle. So I have to do a little more careful work to see what the where this crosses. So 1/2 times the base length, which is, what is it? So what is the slope of this line? It goes from 1, -1 to where? To 2? So it goes up 3 units and over 1. Slope is 3, which means if it's going to go up 1 unit, it's going to go to the right a third of the unit. Okay, so the base length is a third, and the height is not 1, but -1. This gives me a final area of -1/6. How about the area of base 2? That'll be a positive area, also a triangle. So 1/2 times the base length, which should be 2/3 if the other length was 1/3, times the height, which is 2. So this comes out to be a third of 2, which is positive 2/3. And then finally, what is the area of B3? That's a quarter circle. So 1/4 times pi times the radius squared. What's the radius this time? Looks like the radius is 2 squared. So 1/4 times 4 times pi, that is pi. So what does that tell me? If I add those three things together, that gives me the integral here from 1 to 4 of g of x dx. That's equal to negative 1/6 plus 2/3 plus pi. What is 2/3 minus 1/6? That should be negative 1/6 plus 4/6 plus pi. Comes out to 3/6 or a half, so pi plus a half. Okay, so now I'm going to drop these two values in for my integral. So the value of the integral from 1 to 4 of f of x is negative 3. Minus 3 times the value of the integral from 1 to 4 of g of x dx is pi plus a half. So let's go ahead and clean up a little bit. Minus 6 minus 3 pi minus 3 halves, or minus 15 halves. So minus 3 pi minus 15 halves. And a little bit spooked that all my numbers come out to be negative, so let me make sure I agree with that. 2 times f of x, so f of x came out to be negative 3. Okay. And then we just multiplied the g1 by negative 3. Okay. All right, feel good about that. Let's move on to part C. All right, find the exact average value. Okay, so how do I find an average value? So this is actually something that involves an integral. So let's set this up first and see if any of the information we've already dealt with can help us. So if we want to find the average value of f over some integral or interval AB, that comes from this. I'm going to integrate the function with respect to x over that interval AB. And then I'm going to essentially divide the value of that integral by however long the interval was. So this is a calculation you've probably seen. I just kind of described it verbally while I was writing it down. So if I want to find the average value of h of x, essentially what I'm doing is this. I'm going to integrate h of x dx over the interval 0, 4. And I'm going to divide that by 1 over 4, or sorry, multiply that by 1 over 4 minus 0. So I got 1 over 4 times the integral from 0 to 4 of h of x dx. But what is h of x? That's going to be the integral, or sorry, 1/4 times the integral from 0 to 4 of g of x minus f of x dx. But a property we've used a couple of times now is that we can split up these integrals. So basically, with sums and differences, we can kind of treat these one at a time. So let's do this. Let's factor out the 1/4 essentially, because that's another property we have. We can kind of just treat constant multiples, move them around inside and outside the integral. So 1/4 times this quantity, the integral from 0 to 4 of f of x. No, g first. G of x dx plus, no, minus, losing track of stuff, minus the integral from 0 to 4 of f of x dx. Is this something we have found? Not directly, but we can piece it together, because in the previous parts, we found the integral from 0 to 1 of both f and g, and we also found the integral from 1 to 4 of both f and g. So let's kind of expand these a little bit. So instead of saying the integral from 0 to 4 of g of x, I'm going to split this up into two different integrals. The integral from 0 to 1 of g of x dx, plus the integral from 1 to 4 of g of x dx. Same thing with the f. So I have to subtract and I have to distribute basically this whole quantity minus the integral from 0 to 1 of f of x dx, plus the integral from 1 to 4 of f of x dx. So split this up into a bunch of pieces, but these are all pieces that I've already found all these. So let's just kind of substitute in the things I have already found. What is the integral from 0 to 1 of g of x? The integral from 0 to 1 of g of x was negative pi over 4. So this first value is negative pi over 4. I think also on that same slide, I don't know, let's just go in order from left to right here. What's the integral from 1 to 4 of g of x? That came from part B. We said the integral from 1 to 4 of g of x was pi plus a half. So plus pi plus 1/2 minus the integral from 0 to 1 of f of x dx. We said that was 1. So this first value is 1. Plus the integral from 1 to 4 of f of x. We said that was negative 3. So minus 3. So now, because of all the work we've previously done, we had a way to basically handle all these integrals by thinking about them in terms of basically splitting up the intervals and summing them together by moving constant multiples around, by treating sums and differences in ways that made it simpler to handle. So now what remains is to basically clean all these things up and simplify as much as we can. What's negative pi over 4 plus pi? That's 3 pi over 4 plus a half, and there's that minus plus 2 equals 1/4 times 3 pi over 4 plus 5 over 2. And I think we can call it done there. 3 pi over 16 plus 5 eighths. And finally, moving on to part D. For what constant c does the following equation hold? So let's do this first. We can find a value. I mean, there's lots of ways to attack this. I'm going to go through one of them with you, but there are other ways to approach it. Let's find this. Let's find the value of this integral on the right. So the integral from 0 to 4 of f of x plus g of x dx, we've used this a bunch of times now. This is equal to the integral from 0 to 4 of f of x dx plus the integral from 0 to 4 of g of x dx. Is this something are these things I've found? I believe they are. So the integral from 0 to 4 of f of x dx will be basically the sum of the integral from 0 to 1 of f of x dx plus the integral from 1 to 4. So that came out to what? That came out to be negative 2. Actually, maybe I should slow down a little bit. Yeah, let's break these down in terms of so we handled this for both, first from 0 to 1 and then from 1 to 4. let's do that same decomposition here. So the integral from 0 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx plus the integral from 0 to 1 of g of x dx plus the integral from 1 to 4 of g of x dx. So these are all pieces we found. Let's go ahead and drop those in. The two values from f of x are going to come out to be what? 1. So let's do the f and g. The integral of f and g individually from 0 to 1 are 1 and negative pi over 4 respectively. So 1, negative pi over 4. And then how about the last 3 units of the interval? So the integral from 1 to 4 of f of x was negative 3. Then how about the integral from 1 to 4 of g of x? That came out to be pi plus a half. So if I add all these things together, I get negative 2 plus 3 pi over 4 plus a half, or 3 pi over 4 minus 1.5, so minus 3 halves. So this right here is the value of this integral. So now I want to answer this, or let's just re-express what we have here. The integral from 0 to 4 of some constant c dx is equal to 3 pi over 4. Let's do this while I'm at it. Let's find a common denominator. So 3 pi minus 6 all over 4. So what is the integral of a constant over some integral? One of our other properties of integral says this. That's equal to c times basically the length of the interval. So c times 4 minus 0 equals 3 pi minus 6 over 4. So 4c equals 3 pi minus 6 over 4. Let's divide both sides by 4, and what do I get? I get that c equals 3 pi minus 6 over 16. And that'll do it for part D. All right, before